Hello everyone, welcome back. So we're going to do one last example with energy. So it says a cup of coffee with a mass of 58 grams is heated from 70 degrees Fahrenheit to 125 degrees Fahrenheit. Coffee has a specific heat of 4 joules per gram Kelvin. How much energy in units of joules is required to heat the coffee? Well, right off the bat, it should be fairly obvious that this is going to be a thermal energy problem. We have heat here, we've got temperatures right here. We even have specific heat. All these hot words, thermal energy. Now what is our equation for thermal energy? Well, it is Q is equal to M, which is the mass, Cp, which is specific heat, times change in temperature. Change in temperature is the important thing here. It's not temperature, it's change in temperature. And look for that, we have two temperatures, we can figure out temperature change. If everything's in the wrong units, to make things easier myself, because I want joules at the end, I need to get my mass in gram and my temperature change in Kelvin. It's going to be hard. Kelvin, Fahrenheit to Celsius to Kelvin. That's going to take a lot of steps, isn't it? No, actually it's not. It's actually a lot easier than you think. So we'll do, well, grams is already there. So all we need to do is mess with the temperature change. So my delta T in Fahrenheit is going to be equal to 55 degrees Fahrenheit. And you might be thinking, oh goodness, I have to convert that to Celsius and to Kelvin. You don't actually, because this is temperature change. I can use conversion factors when it's a temperature change. I have to use an equation when it's just temperature. And so all I have to do is this. There are 1.8 degrees Fahrenheit and 1 Kelvin. It's all about step size here. This is only for temperature change. So let's plug it in. So bring up my calculator. 55 divided by 1.8. It's going to be 30.55. Okay. 30.55 Kelvin. And that's everything. It's that easy. So that's going to be equal to 58 times 4 times 30.55. Once again, write out your units. I'm saving myself some time here so I don't keep you forever. And also my handwriting's pretty terrible. So, write your units. You know what? I'm going to do it. Equals 58 grams times 4 joules per gram Kelvin times 30.55 Kelvin. Kelvin cancels, grams cancels, I'm left with joules. I can do it. Who would have guessed? What's the answer? Let's go ahead to the next slide and see what the answer would be. And the answer would be 57,444 joules. You're like, whoa, that's a lot of energy. Is it? Joules are actually a very small unit of energy. Tiny. So don't be too impressed by this, honestly. It's still quite a bit, but it's not crazy. So, 57,444 joules. Not bad at all. And you can see they did everything the same way we did. Oh! They didn't do everything quite the same thing we did, because our problem statement said 58, and that right there, if you look at it, says 470. So this number is actually a lot bigger than it should be. Okay, how about this? I'll plug in the numbers for ours to see what it should come out to be. Some of you probably be confused otherwise. 58 times 4 times 30.55. Whoop. 30.55. 7,087 joules. Okay. A little bit more reasonable number here. So you can always make sure that the problem statement and the solution you're looking at are the same. Well, I hope this helped you. Had another example with energy. This will be the last one for this. And I'll see all of you next time. Bye-bye.